Yes, me again. I have been asked to give a presentation about risk assessment and risk management, which was a kind of development, let's say, the start of 2004, 2006 in Europe, and it was a project that I coordinated. And I will give you an overview what has happened since, and just to give you an idea what kind of development there is in Europe, maybe not only in Europe, but especially in our laboratory. My presentation, I will start with the first introduction, why we started in Europe this kind of research. I will give you a little bit insight on the risk analysis framework on food safety in Europe. Then I will talk about the big project that has been set up, starting in 2004, to deal with the problems that were present at that time. Then I will come into the monitoring of development of monitoring of contaminants, a different approach than Boris just told me, that that's also one of the things that we are doing. So I think it is very good development. Then I will talk about emerging food safety risk and what is done in the Netherlands, and come to some conclusions. Well, at the beginning of the 2000s, there was a lot of incidents in the media on food safety in Europe. A lot of problems with the quality of food, dioxins, antibiotics, and so on. So there were a lot of food safety incidents, and there was a low trust in the way the governments were dealing with the crises and how they handled it. And so there was also not so big trust in the regulatory system in Europe. So because of these things, it was decided that, well, the government and the European Commission had to do something about it in order to restore the public trust in the food and food safety in Europe. So that's why a EU white paper on food safety was developed in that period, 2000, I think it was published in 2002. And in that white paper, the strategic priorities were laid down, and that was, among others, the establishment of the Food Safety Authority, EFSA, that was established in 2002. Also, the farm to fork approach was more described precisely, and also the legislation was set down, and also defined the responsibility for food safety, who is responsible for what in the food production. Also, the general food law was established in 2002, and also a rapid alert system for food and feed. That was also part of the new legislation. This is just how risk management, risk analysis is organized. This is taken from after the WHO in 1998, and this system is set up to minimize the risks, the risk of food safety. And it has three components. First, the risk assessment, which includes hazard identification, hazard characterization, exposure assessment, and the risk characterizations. Generally, these activities are done by risk assessors, which is a scientific-based activity. Then we have another group of people, the risk managers, and they are involved in assess the policy alternatives, to select and implement appropriate options. These are the managers working on the industry. Then there is a common activity, risk communication, which is, well, talking to the public, to all the stakeholders on food safety risks. The idea in 1998 is that there should be a clear separation between the risk assessors and the risk managers, because they have different responsibilities. Later on, it became clear that, of course, they have different responsibilities, but there needs to be a tight link, good interaction between them in order to get a proper communication. So the risk assessors are in the EFSA, which are located in Parma, and the European Commission, which are the risk managers, are located in Brussels. And so together they are responsible for the risk communication. This is on the European level, but the same was done in every member state. So also there, we have a group of risk assessors, risk managers, and risk communication is a shared responsibility. But it became clear that this system needs some reform as well. It was not completely functioning as it should. One of the things is that the system only focused on single risk issues, only one hazard at a time. The responsibility of the different stakeholders was not always as clear as it should be. And I will show you a little bit later on that. And the process of the risk analysis was not very transparent. It was not always clear how the different values were weighted and how the decisions were taken. There were also no systematic consideration on the potential benefits, because there might be some hazard there, but there might be huge benefits as well. And how is that weighted, and how is that taken into account? The economic consequences and the social values and attitudes. There was also no systematic way of doing that. And also no formal participation and representative stakeholders in the whole process. That was also one of the things that needs to be addressed and improved. So here are the things that I just talked about. There should be in the risk analysis, it should be more integrated the benefit consideration, environmental impact issues, animal welfare, acceptability of cultural attitudes, and social economic impacts. So that should also be taken into consideration, and it should be a more structured way of doing that. Well, these were the questions that were addressed in a very big program that started in 2004, included 37 partners, research organizations from 21 countries, and we had almost 50 million euros to spend in 4 years' time. And here's the location. Also China was involved, and South Africa as well. And together with Harry Kuiper, we were coordinated at RIKILT. This was a big program, and I'm not going to show you all of it, but only the things that were associated with the integrated results that we had to improve the proposal that we made to improve the risk analysis framework. Several books were published. We also have published a special issue in food control. It was published in 2010 and volume 21. There you can find all the details how we came to this new framework. A lot of stakeholders were involved. We used Delphi methods, stakeholders consultation different ways, experts from outside Europe, inside Europe. It was a whole process. At the end, we came to more or less 4 distinct actions or activities in the circle of risk analysis. So there should be a process starting with a framing. In the framing process, it is an activity. Here it says who is doing what. The yellow one is risk assessor, so a scientist. That can be scientists from academia, but also from industry. And risk managers, which is, let's say, the managers and authorities. This is an activity that you should do together. Not specifically risk assessors, the scientists, or the risk managers, but together. And here you identify the risk, the costs, the benefits, and their distribution. Also the risk profiling is done, identification of decision options, and criteria for evaluation of the results. And also, I will talk a little bit about that later on, is to monitor the indicators. When you have done the whole things and you have made the decisions and implemented the activities, you need to monitor the effect, and you have to decide beforehand how to do it. That you agree that's the way you will do it. Also early warning indicators and allocation of resources. Because there's always a balance between how much money can you spend, or do you want to spend, in order to reduce a specific amount of risk. What's acceptable, and you need to have an agreement on that. So here you determine how much you can spend and what time of what issues are at stake, then the risk assessors will start to do their work. The risk assessors should also not only look at risk, but also the benefit assessment. And not only on the health, but environment, social, economic, and ethical assessments. Of course, not every risk should be dealt with in the same way, but here you together decide whether there should be an ethical assessment, whether environmental assessment is needed, or only health, and so on. And then, of course, we do all this. Of course, when a risk assessment is starting to do the work, they can come back and say, well, this is too little money available in order to deliver the answers that you are asking for. So this is an iterative process. Then something comes out, then there's the evaluation process together with the risk assessor and risk managers, and here they ask the questions, have the risk assessors delivered answers that we have asked? Are the answers satisfactory? Not weighting the different outcomes, but only assessing, yes, we have now the answers. If that's okay, then the risk managers make the decisions in a transparent way, showing how the benefits and the risk have been evaluated against the animal welfare things, economic impact and quality of life issues, and so on. So then, of course, when the decision has been made, then there's a control and implementation of the things, and then a review. So all of these steps have been described in more detail. Now I would like to focus, because that's what we are doing at RIKILT, at early warning, at indicators of early warning, so emerging risks, how to monitoring it, and also the decision and how to monitor unintended effects. Well, as I mentioned in the beginning, already with the General Food Law, the European Food Safety Authority was established, but also the monitoring system called the Rapid Alert for Food and Feed. This is a centralized system, Rapid Alert System for Food and Feed, centralized, and it is required by the General Food Law, as I mentioned, and EU member states are involved, EFTA countries, which includes Norway, and also, of course, the Commission. The number of countries are now bigger because there are more member states. I haven't updated that. You can, if you want, tap into this system. Every day, every week, the new information is updated and it is open for everyone. So, and in the system, you will find notifications. And notifications are alerts of importance for other member states in regards to the monitoring of contaminants. Chemical contaminants, microbials, and so on. For all things that need to be checked in regard to food safety, which is all the long list of the chemicals that Boris already showed you. And here, alerts means this contamination can move into the other country, so the other country needs to do something about it. Check the specific lots. Then there is also notifications in information form. Here it is not necessarily a direct food safety risk for another country, but it is nice to know. So yeah, so there you can build your own idea about specific issues. Here, in this case, there is a food safety issue, but it is confined to the country where it is found. Of course, also border rejections before they come into the EU, also these are reported. If there's a higher contamination than allowed. There's a weekly and annual reports and so on. But here, only known hazards are reported. And all the member states contribute to this system. So all the member states report every week what they have found in the monitoring program. So RIKILT, together with the Dutch Food Authority, are doing that for the Netherlands. So we report every week into the system. There are some constraints, so you can have a look and see how many. There are lots of reports here. But because the constraints are only known hazard, it is reactive. So, and that is, let's say, basically every monitoring program is reactive. Because when you find a potential elevated concentration of a contaminant, then it is already there, because you take a sample from the market. So you always are proactive. It is costly because, well, Boris gave an example of cheaper possibilities, but generally you have to measure one by one the chemicals. That means a lot of chemicals need to be, or contaminants need to be checked. That means a lot of work and costly. You only can use it as an early warning system. That is, if in Spain they find high concentration of mycotoxins because of specific conditions, Spain is not Holland, but maybe it may move to Holland, so then you can take a proper action. In that way, it can be an early warning. When this was set up, and we had a lot of discussion with the European Food Safety Authority and also with our ministry in the Netherlands, and I have to say, well, these are reactive systems. That means if there is high, let's say, contamination in the food system, then you still have this report in the media saying we have higher elevation and so on, and that still can cause public distrust in the system when you do your really good job to prevent the things coming into the market. So you need to be ahead of that, making sure that you can be more proactive. And EFSA agreed on that in our discussions, and then they said, well, okay, we need to be more what they call immersion risk identification. And here's a nice definition. I think Helene also showed you one developed later on. But EFSA adopted this one as that immersion risk to human, animal, and plant health is understood as a risk resulting from a not newly identified hazard to which a significant exposure may occur, or an unexpected new or increased significant exposure or susceptibility to a known hazard. So, new and old. Well, in 2007 this was set up, and we had all kind of discussion and research together with the authority. And so we had looked at what kind of system is out there, and are there really these immersion risk systems. And when we looked at all the systems that have been developed or are being developed, we came to these three types. You have endpoint or hazard flow systems, which I just showed you. You have also predicted approaches for known hazard. These kind of systems, I had a few slides, but I've taken them out, are predicting, for example, the contamination of mycotoxins in maize or other crops. Because you can predict it based on the weather condition. When maize is flowering, you can predict how much mycotoxins you will find at the harvest time, which gives you 3-4 more times to react to it. But I will now focus more on the predicted approaches for known and unknown hazard based on a holistic approach. That's a concept that we have developed in several. Sorry. One example, some new approaches here. I only have a few slides there. What you see in development, because of measuring of the one single compounds, you can use bioassays, which is rapid and also can have more. In Europe and in the Netherlands, you will see that you get more untargeted fingerprint methods. That means that you measure thousands of compounds in one time and created a fingerprint of saying, okay, this fingerprint is not contaminated. And when you get deviation from that, you know that you have compounds in there that should not be there. And when you have a crossing above this threshold, then you go into detail what a specific compound is that. So in that way, you can measure many compounds very quickly in the same round, so cheaper. So this is just saying how it is. In the past, in the traditional system, you decide what you want to know and then you perform the analysis. With the fingerprinting, you do the analysis, you measure a lot of compounds, you get a lot of peaks. And if you get deviation from what is considered safe, then you decide what you want to know. So In the past, you did the sample preparation was a big issue to get the compound of interest pure for the analysis. But now you put more emphasis nowadays with the profiling on the analysis computer time. So cleaning up, not in the sample, but cleaning up in the chromatograph. So that's a new development that we are at the RIKILT doing. Now I come to the holistic approach as a promise. The holistic approach comes from OCD, in fact from another domain, not in food safety domain, where they looked at the effect of developments outside your own domain. And I will show you here for the food chain. This is a graph made by in a project called PERIAD, coordinated by the Dutch Food Authority. It was an EU project, and there they have put 50 different experts from many different disciplines. So there were natural scientists, there were social scientists, ethical scientists, financial scientists, legal scientists, in one room like this. And 2 days we discussed whether and in which way development in that domain can have an effect on development of a food safety problem within food production chain. So we came up with these domains, science and technology, for example. Just give a few examples. GMO, genetic modified crops. I mean, that can also cause potential food safety problems, or nanotechnology. These are new technologies. For example, we have crises in the Netherlands that have to do with the developments in government or in the politics. One word was legislation. No words legislation. Well, let's say that government is also part of legislation. The legislation was changed. The industry adapted to the new legislations, but made a wrong choice, which they didn't know. And the consequence of that was contamination of the milk with dioxins. And we found that later on in the monitoring program of milk. But the reason for it was a change in legislation. And if they were taking better care of that, what the consequence could be, if you understand that, then they could have been more proactive. And so, and all these agriculture, economic and finances, for example, economic, if the price of commodity increases, you have a bit more chance of fraud, which is a food safety problem. So you can, if you understand correctly, we call these drivers, how it will affect the performance of the food chain, also the food safety, then you can make a prediction models using it. And I will show you how we have done that. This concept of a holistic approach, how external things affect the performance of food chain, have been done in a series of projects in which we or someone else were, from the Netherlands were involved, starting in 2001 until 2010. And I will give you a few examples, because most of them I was self-involved or was coordinator. And I will give you here one example of this holistic approach which have been published for the dairy chain in the Netherlands. So these are 2 steps in the dairy chain. The feed manufacturer in the dairy farm, and then of course you have the processing into the mill. What are the critical factors in these 2 steps? First, with the feed manufacturer. The feed ingredients are, they use feed ingredients. When they change, they have the normal control, but when they have new sources of raw materials, potentially that can cause harm. If they then, for example, import the proteins from a new source that they don't have much, but is cheaper, but they don't have much experience in controlling, that potentially can lead to new food safety risks. And we have examples of these. The presence of a quality system of feed ingredients supplies, and how well they are keeping that quality systems. The feed ingredient traceability, for example. Then also the historic of compliance. because some suppliers have caused some problems or not. Some have good contacts. Also the cultures of the suppliers, the best farm practices, performances, and so on. So all these kind of things. Here some, the compound feed, for example, the complexity of the product. The more complex, the more chance of risks. The condition of compound feed storage. The cleaning and disinfections and procedures for all that. And the quality system compound for the feed suppliers. And I'm not going into detail, but you have in the dairy farm exactly the same kind of potentially risk, where risk can occur. But you can also take the whole chain, the dairy chain, supply chain, for example, the firm sizes. Are there many small organizations? The chain organizations, is it the web that constantly changes? How is the contracts? Is it, the profit margins? Are they big? Or are they very narrow? So that when prices change, they need to adapt very quickly. And how do they adapt? What is the history of that? The possibility of economic fraud. These are all characteristics that you can figure out by thinking of it, discussing, talking to the chain actors. So, then is how all these critical factors shown here are affected by drivers, such as the climate change, changing weather conditions, changing prices, changing trade, changing technology, and so on. If you know that, how they will affect, then you need to find data sources that provide information of the changes in the drivers. So then you follow the data sources that happened, the changing drivers, before it really occurs, because you know the relationships. That's what we have done in a project called Emerging Risk Detection Support System, which is a Dutch project, which I coordinated, where we have applied the system to develop a prototype. A prototype for, in our case, the salmon case, because we chose that. This system is a expert knowledge systems, all put down in the computer, and I will show you how it works. But at the same time, it can follow information from the web, from data sources that we have identified, which can be rainfall, which can be economic, if the prices of the proteins or the stock and so on, the trades, the changes in trades. These are all available. That is collected from the internet, online, and then used here in the system to warn you for potentially risks. It sounds maybe very complicated, but really it's not a big problem. How the basic of how the system works. We now make use of artificial knowledge and reasoning and so on. So this knowledge base of Emerging Risk Detection Support System exists of, well, this is what it is. It's a knowledge-based system or an expert system. It tries to reproduce the reasoning of human experts and to interfere new previous facts which are unknown to the system. So you try to mimic what people do in our heads, but then a lot of experts together, you try to mimic that. And you can use a lot of information. So the computer can have direct access to a lot of information. And this system, this knowledge system, works with 3 components: concepts, facts, and rules. And just briefly we'll show you what this is. Concepts. These are things. What is a thing? A thing is Atlantic Ocean, Yukon River, salmon, Moscow, Amsterdam. That doesn't mean anything. It is just, or a human. If there is no fact associated to a thing, it doesn't mean anything. Because we know by ourselves that if you see Hans Marvin, that is a man, and so on. But that's a fact that you already know. So when you have described the world in concepts, you have to give meaning to the concept with facts. An example here is Atlantic Ocean is an ocean. You then have to describe what fish is. Fish swims in water, can eat, and so on. So all of that needs to be described. And then you will create facts with the help of experts. And the facts, rules. Rules combines the facts that are present in a system and create new facts. And it's often if-then. If a fish swims in the water and the water gets contaminated, the fish gets contaminated. And so all kind of rules you have to extract for a specific system from experts. All the different kind of experts. If prices goes up, that organization might do some fraud. Or many other things. There are groups in America that already describe, there are many groups, describing the world in a way with concepts and facts. So you only need to download it and to adapt it to exactly what you need. And with the help of experts, you create your expert rules. Well, we have done that for the fish, and we demonstrated that in the ministry, and they said, okay, this is a very good concept. We showed the proof of principle that can be done, and so they started a project which is called Apollon, and in order to really create a system based on this. I was not involved in that because it was someone else who got the contract. But they had to use the same concept I described and also the same kind of approach. This is a immersion risk system developed at NVWA, which is the Dutch Food Safety Authority. And this project started in 2010 and 2012. It was a little bit later extended. Which Waterbornies was the contact at that time. The key question in the Apollon research: how can the concept of immersion risk detection support system, just think what I just told you, can be used for information analysis, to be used to develop a comprehensive system to allow governments timely and effectively identify new food safety, plant health or animal health hazards in the slaughter pig industry in order to assess risk in public health. So how can we develop this kind of system for the pig chain in the Netherlands? I only have one slide, one slide of this. What they did is basically what I told you, describing first the mapping the meat pork production chain in the Netherlands, all the steps, and then find the risk factors, and from the risk factor find the data sources, and the data as I mentioned here, and then identify indicators and knowledge rules, so what if situations, and at the end they constructed the Apollon system, which is now functioning and working for a big chain in the Netherlands. Real details, there is a publication, but I think it is in Dutch, so available on the internet how this system works, but so you need to translate it. My conclusions from my talk is that food safety is an international issue, and we therefore need to collaborate and exchange information. And I think it is a benefit of all of us by doing that. And past experience has shown you that it can be beneficial, it is beneficial for all of us. I really think that holistic approach to predict food safety risk can be done, is useful, and we have an experience, an example that it really can be made. And also there are many software tools, I haven't gone into detail, or more software tools that can be used for the identification and prioritization of immersion risk. However, my experience is that expert judgment somehow is always needed. So you're not a blind person behind a computer can tick in and then get a red light, oh now it's a big problem. You need an expert to judge exactly what's going on. Thank you very much. And now the chair is asking other questions. Julian?
Yeah. Hans, I think you gave us a very good presentation for the past few, nearly 10 years. You have this EU project. You are successful to get that. I'm interested that's why you could successful continually to get 3 EU projects. Could you share us the experience for this project application? Yeah, thank you. Yeah, I think since 2004 you are got the settlement project and then go global and then there's
Collab4safety?
Yeah, that's you continually successful get this 3 EU project. Yes, that's the big. I think it's a very good achievement for their project application. I think now we try to some of these people just give an introduction for the like college to 2020. You also we could get some chance for the project application. Yes.
Well, in Horizon 2020, we will try to get some.
No. Yeah, just I try to know how do you could get the very successful project application. Yeah, that's I think is also.
How to do it?
Yeah. What your major experience?
Well, okay, that question. First of all, you need very good partners, and you are one of them, and INVI, because you need good partners to write a good proposal, because you need to be better than the other ones, and so this is a very high competition. So you have to read the call text very carefully and try to understand what is the reason and what they really want to have achieved, and then you need to find the best partners to do the job, because you need to convince the evaluator who is going to read it to convince that we have done the best proposal for the cheapest price, but also the best science and the highest impact for society, because these are now very important criteria. How the society will benefit from the work is done in a project. And you will see that the topics are not so simple as develop a new method for mycotoxin analysis or how to do pesticide analysis. No, you get bigger themes. So then that means that projects will be multidisciplinary, not only on scientific issues, so you need to involve social scientists, economic scientists often, natural scientists, but also industry, just all the stakeholders, NGOs, not only in one country, but European-wide or global. So you need to be very carefully in constructing your consortium, but at the same time you need to show you have had an effective, good collaboration in your proposal with the partners that you propose to take on board. And if you can say, okay, we have done already 3 projects together, and so IPP CAS is a very good partner in this, so this helps to convince the evaluator.
Thank you.
Okay, another question?
Можно я на русском задам? У меня вопрос такой. Вот вы сказали очень интересное применение идеи искусственного интеллекта к решению задач безопасности. Вот вы используете готовую оболочку какой-то экспертной системы? Или вы создали свою? И вот вы сказали о создании базы знаний для рыбы, для рыбной продукции. А есть ли у вас другие базы данных для других видов продуктов? И они открыты вообще для доступа?
Thank you for your questions. I'm afraid that the principle is open, but not the results of the project. Apollon is a system of the pig industry, but also the industry involved in the Netherlands. And so that, not even I have full access to what is going on there. From the ZAR, that was only to show the potential of this approach, because at that time no one thought that this was possible. And now we will use the same kind of technology for food security prediction and how the performance. So we will write new proposals in order to get funding to develop this kind of system. And I can tell you, there will be this kind of approaches in Horizon 2020 on big issues as food security. But nowadays, the European Commission will demand open access to data. I think that's a new trend that was not in the past, so that when results are generated partly with public money, I'm not exactly know in which way, this should be open. Also the raw data, not the publication, but also the raw data should be public available on the website. Maybe they can add more to that, but I know that that is a new trend in Horizon 2020. So, but going back to your question, whether the sound information that we have generated, no, this is not available for the public. Only the concept we have published, how it works. But I'm sure in the near future this will become more common.
Okay, just a small compliment. Open access data, that will be pursued under Horizon 2020. But let me say that also in the past under FP7 the principle already existed, and it was applied on a voluntary basis. Not always with success. And we always did that in a very gentleman way. We never imposed, we were always waiting for the publications. But it is a little bit a waste of taxpayers' money if you cannot access the information, or let's say the data, which is the basis for all the scientific information. Because then it happens that you have to start with the same research all over again. That is something that we wish to avoid, and for that reason, open access data will be applied systematically, but of course with respect for scientific publications.
Or maybe just to make clear, the Emergency Risk Detection Report System, the SAM, that was a national project, funded directly from the ministry in Holland. The safe foods, let's say the concept development and so on, these have all been published and all available. But that's not exactly what you were aiming for, how this concept and the rules and the reasoning is done. But that will be more common in Horizon 2020. I see a proposal, and they will use how do you call it, Bayesian's networking and ontologies in order to develop reasoning systems in more domains than only in food security and food safety.